going to look at a second method of doing the exact same equations. This one's a tiny bit more messy, but it is the one that I actually use. So all I have to do first of all is write out each atom and how many there are. So Na2, that means that there's 2 sodium atoms. There's 1 sulfur and 3 oxygens. 2 hydrogens, 1 sulfur, 4 oxygens. Over here on the right hand side, 2 sodiums, 1 sulfur, 4 oxygens, and then so on. So now what I would do is I would just count. So let's look at the sodiums and the sulfurs first. When you're balancing equations, you usually leave hydrogen and oxygen to last, because sometimes there's a water molecule which you can balance everything out at the end. So focus on the other elements other than hydrogen and oxygen first. So here, 2 sodiums, they're balanced. 1, 2, 2 sulfurs, 1, 2, 2 sulfurs. Let's go to the oxygens. 1, 2, 3, 7, 4, 5, 6, 7. Oxygens are balanced. Let's look at hydrogens. 2 hydrogens, 2 hydrogens. So this balanced equation is already balanced, so I don't need to add in any bigger numbers to work on the ratios between the compounds. So let's look at this one. 1 carbon, 2 oxygens. 2 hydrogens, 1 oxygen. 6 carbons. 12 hydrogens. And 6 oxygens. And then 2 more. Okay, let's look at the carbons first. So we have a major imbalance here. The 6 on the right hand side, only 1 on this side. So I'm going to multiply this by 6. When I do that, I'm going to write out that I have 6 carbons now. And then 6 times 2, the 2 beside the oxygen there, is going to give me 12 oxygens. There we go. And let's look at the hydrogens. I have 12 hydrogens on the right hand side. And I have H2O, so I have 2 H's already there. So what do I need to multiply 2 by to get 12? That would be a 6, wouldn't it? So now I have 12 hydrogens on this side as well. And don't forget to multiply that 6 by the oxygen also. Okay. So I've done carbons, I've done hydrogens. Now let's look at the oxygens. So on this side, I have 12 oxygens plus 6, 18 oxygens on that side. And I have 6 plus 2, 8 oxygens on this side. So the thing is that I've looked at this molecule already, and I don't want to multiply a number by that molecule, because I've already balanced the left hand side with the carbons and hydrogens based on the number C6H12. So I'm going to try and work with this guy here, this little space there, to balance off the rest of the equation. So 18 on this side. I don't want to do anything with this guy. So what I'm going to do is, what's 18 take away 6? That's 12. So I need to somehow make 12 oxygens here in this little section. So there's already 2 of them. What do I need to multiply it by? Let's do 6. And that will give us 6 oxygens. So in total, we should have 18 oxygens on that side now. So it should be all balanced. Okay, so same thing, 1 lead. This 2 outside the brackets is multiplied into the whole complex ion there. So I have 2 nitrogens and 6 oxygens. So remember to multiply everything in the brackets. 2 hydrogens, 1 sulfur, 4 oxygens. 1 lead, 1 sulfur, 4 oxygens. 1 hydrogen, 1 nitrogen, and 3 oxygens. Okay, so the leads seem to be balanced, 1 Pb on either side. The sulfurs are balanced, 1 S on either side. The nitrogens are not balanced, so we have 2 here and only 1 here. So I'm going to have to put in a 2 right there. Multiply 2 into everything. 2 by 1H is 2 H's. 2 by 1N is 2 N's. 2 by 3 oxygens is 6 oxygens. Okay, now we've just the oxygens left. So count them up. 6 plus 4 is 10 oxygens this side. 4 plus 6 is 10 oxygens that side. So it's a tiny bit more messy compared to the other method in the different video, but I just think this is quicker and it's clearer for me to do it this way. And if it's clear for you, definitely go ahead and do this. The examiner is not going to mind that you do it a certain method as long as the answer is correct.